Can you people see my screen?
No, not yet.
Not yet.
Not yet.
No.
Okay,
No.
let's give it a few minutes. You're still not able to see it?
Yes.
Visible now.
Okay, fine. So, we want to talk about something called exceptions and assertions. What an exception is in a programming language is that basically it's an error. Okay? You are going to make mistakes.
The screen is
The screen. Oh, I see. Yeah. Tell me when you can see it. Are you able to see my screen?
no. Okay, yes.
Yes.
Okay, so we are going to talk about two things in this chapter: exceptions and assertions. Now, an exception is an error which causes your program to come to an end. In other words, your program crashes. That's an exception. And there are many types of errors which you can make, which will cause your program to crash. So when an error happens, the same way when you're opening a file, when an error happens, this is an event. When an error happens, Python creates an object which tells us what kind of error we have committed or what kind of mistake we have committed. So that is exceptions. So there's a way of handling these exceptions such that your program does not suddenly come to a stop. Then Python is spitting all sorts of information on the screen which is going to scare the person who is running your program. So you maybe want to handle that situation in a more delicate manner. The fact, as we are going to see, is that whenever you commit a mistake or an error, Python is going to bring a red pen and show you, say, you've committed a mistake here. So there is really no forgiveness when it comes to Python and errors. So all the errors you make, Python is going to point them out to you, and everything will come to a stop until you either choose to address that error or you don't do anything about it. Okay? So basically, you're not going to be forgiven for committing an error. If you're not going to be forgiven for committing an error, and you are going to commit errors whether you like it or not, in that your program an error might happen, or someone might give your program wrong information to cause it to crash. Okay? You have to handle these events in a certain way. The first thing really is you really don't want, because there is an error, you really don't want things to come to a halt just like that. Are we clear? So what we're going to be looking at is how do you handle errors which are going to arise as your program runs. Some of these errors, even you will know about them before they occur. Say, this kind of information can cause an error. So how do you actually make sure that such kind of information does not get into your program? That's where this bit assertion comes in. You assert, you check the information, the piece of information. Maybe the only kind of numbers you need, which your program is going to use, are positive numbers. But here you have a person who doesn't know that the negative number will cause your program to an error in your program and that your program is going to crash. So you want to make sure you tell the person, say, no, this program, oh, you have given me, I've looked at the number you've given me and the number is negative, but I don't accept negative numbers. So that's where assertion is. So part of your handling errors or exceptions is making sure that your program, which you're going to write, accepts the right kind of information. So you assert, you check beforehand if the information your program is being given, because you can get information from everywhere. As you have seen, we can get information from a file, or we know you can get information from the keyboard, you can get information from all over the place. So you want to make sure that this information does not cause your program to come to an end. So that's where assertion is. Exceptions are the errors which will cause your program to come to an end. So Python is going to tell you, oh, your program has come to an end, and this is the reason why it came to an end. Are we clear? Is that clear?
Yes.
Okay. So, what is the philosophy when it comes to handling errors? So we import this module, a module called this, and there is something very interesting it says about errors. And when it comes to Python, what is the idea behind Python and how do we handle errors? So it's a couple of things. The first thing it says is that beautiful is better than ugly, explicit is better than implicit, simple is better than complex, complex is better than complicated, flat is better than nested, space is better than dense, readability counts, special cases aren't special enough to break the rules, although practicality beats purity. Now, this is what we are interested in. Errors should never pass silently unless explicitly silenced. In the face of ambiguity, refuse the temptations to guess. There should be one and preferably only one obvious way to do it, although the way may not be obvious at first unless you're Dutch. Now is better than never, although never is often better than right now. If the implementation is hard to explain, it's a bad idea. If the implementation is easy to explain, it's a good idea. Namespaces are one honking great idea. Let's do more of those. What we are interested in here is what it says in what you have highlighted here. Errors should never pass silently. So if there is an error in your program, the idea behind Python is that if there is an error, no matter how many errors are there, it's going to scream at you, say, this is an error, fix it. That way, when you fix your errors as they appear, it makes it easier for you to come up with a program which works quickly. Okay? Then it goes on to say, unless explicitly silenced. So there is actually a way in which, even if your program has an error, there is a way in which you can handle these errors so that these errors don't make your program come to an end, terminating. And that is what we're going to see. Okay? And that is what is called handling exceptions. Now, the way you handle an exception is by using the following structure. What is called a try, except, else, and finally block. So this is the way it works. So if you suspect, if you have a strong suspicion that a certain line of Python code which you want to run will cause an error. Okay, it's not every line. Certain lines are obvious. I've done everything right here, so this will not cause an error. But if you have a strong suspicion to say, if I run this line of code, this line of code is going to cause an error, then what you do is you put that line of code in what is known as a try block. So you start with try, then after the try you put colons, 2 colons, then you put the line of code you suspect is going to cause an error. Are we clear?
Yes.
Yes. If there is a line of Python code you think might cause an error, that line of Python code, you have to put it behind a try, so that Python tries to run that Python line of code. If it doesn't cause an error, fine, things go on. But if it tries to run this line of code, then this line of code causes an error. Then, after it causes an error, what should be done? So here are the options. So the first is except here. So after an error occurs, then what should you do? So there is another message here: execute this code. So if an error occurs, you're being given a way out. Instead of your program coming to an end because of the error which has happened, you want to do something about that. Maybe you want to tell the person, say, there's an error. Okay? So you can do an except here. Then sometimes some of these excepts, then you run some code, or if after this except you can also, there's an else, then you run some code, then finally you run some code. So basically you've got a bunch of options you can go through in order to address this error. Is that clear? And then we're going to see how this works, this handling of exceptions. So the first thing we're going to look at is the first part here: the try, then execute code, then except, then execute code. Just this top part here. We're going to see how this works before we come to these other parts here. So this is what is referred, the top part is what is called a try except statement, or a try except block. A try except block. A try except statement, or a try except block. So basically you try to do something, then if it doesn't work, then what should you do? Yeah, the try, then except block. So you are going to try to do something. What you're going to, the only things you try to do are those things which cause an error. If you know something is going to cause an error, so, and that's what you're going to put here. You try to run this piece of code you think is going to cause an error. Then when an error happens, then what should happen? That's where the except comes in. Then you execute this other code. It's like an if else, but this one is what you use for handling errors. For example, here is something which is definitely going to cause an error. I want to print out number. But since I started this, as you can see, Python does not allow you, from our knowledge of Python and variables, Python does not allow you to print a variable you have not given a value. In this case, as you can see here, this number has not been given a value anywhere. So if I try to print this number, in the case of you trying to print a variable you have not given a value, this is going to cause an error. I run this, and of course, I'm not forgiven for making this error. So Python comes out with a red pen and says you've committed an error, and the name of the error is called name error, and it even points out which line it has a problem with. It says this a problem with this line, print number, and in this print number, what exactly does it have a problem with? Excuse me. It says name number is not defined. So it doesn't matter how many times you're going to run this. Python is going to keep on showing us this message that I have a problem with number because number does not have a value. And I'm not allowed to print variables which do not have values. This is an exception. The name, so this is an error, and this error has a name. It's called a name error. So this is an exception which happened, or an error, an event which happened, where we tried to print a variable which does not have a value, and Python had an issue with that. So it brought this to our attention, and our program, whatever it is we're trying to do, came to an end. Are we clear? Yeah, so what do we
Yes.
do about this? How do we handle an error like this? So if we try to print a variable, you're not sure whether this variable has got a value or not, you try to print it, and you're sure, okay, this might cause an error, then you need to put that statement in a try except block. So here, this is the message you got, name error. So when you say try, now we say try, then at the end of the try, you put your colon, then you print number. Now the error changes. It's no longer a name error. Okay? It's no longer a name error, but it's a different type of error. Something called a syntax error. Now, a syntax error is how the rules of a language. In this case, what Python is trying to tell us is that, okay, I tried to do this try business, but it is not complete. The reason why it is not complete because try moves along with except. So it tried to carry out the try, but there was no except. Are we clear? So it tells us, no, I have found a different type of error, a syntax error. So it's no longer complaining about the number. It's complaining about this try block not being complete because there's a missing part. Whenever you have a try, you need to have at least one except. Is that clear? Are we clear? So that's what we do here. So we say try, print number, then we put except. Then at the end of the except, we put the colon there. When we do this, we run it. Then it tells us there is an error after the except. And what is the error after the except? Because after the except, you're supposed to do something. Okay? After the except, if there's an error which has occurred, you are supposed to do something. Anything. Sometimes you can do nothing. For example, in the following case, we might do nothing. But if you're going to do nothing, then you have to explicitly tell Python that we are doing nothing about this. So you put a pass there. There. There is an error which has occurred, but now finally you don't see any error messages, any error things on your screen. You have managed to silence the error. This is what this thing is saying here. Errors should never pass silently unless explicitly silenced. The problem is when an error occurs, then you're just quiet. Your program is not saying anything. You are just quiet. The person who is using your program will have no idea that something wrong has occurred. Is that clear? It's better if an error occurs, you say something at least to alert the person who is using your program that there has been an error or a mistake has happened. So just keeping quiet like this, doing the past business, yes, it silences the error, but this is not a good idea. It's better you say something. Say an error has occurred. If you've got more information about what kind of error has occurred, you can also say what kind of error has occurred. Is that clear? So it's not a good idea to just keep quiet as if nothing has happened. Okay? So instead of pass, we are going to print a message saying an exception occurred. So when you do this, then because Python will try to print out this number, but it doesn't have any value in it. So instead of doing that, it's going to print out an exception, telling us that an exception has occurred. So this is what we get here. An exception has occurred. So our program has not come to an end because of the mistake which happened, and at the same time, we are now aware that there has been a problem. Are we clear?
Yes.
Yes, we are now aware that there has been a problem. We tried to print a number, but Python tried to carry out our instructions, but it ran into a problem, and it alerts us that there has been a problem. We print a nice message saying, oh, there's been a problem. Unlike having messages like this, or like this, where it spews out a lot of things, like you have committed a lot of sin. Yes, it's an error, but yeah, much better than this. So this is what we mean when you're handling exceptions. When an error occurs, you want to find a gentle way of handling this situation. Okay? Unlike where a program just comes to an end. Now, as you can see, we had here, we had something called a name error. Name error. This is the name of an exception. We had something called a syntax error. This is also the name of an exception. Another syntax error here. What this is trying to tell you is that different events which cause errors, the common ones actually have got names. Exceptions have got names. Okay, there are some errors in Python which can cause your program to come to an end, and we know about these errors, and they have names. So we're going to go through a list of some names. For example, just exception itself, that's a general name for these errors. Then there's something called the stop iterates. Then there's something called the system exit. There's something called a standard error, then an arithmetic error, then an overflow error, a floating point error, zero division error. This zero division error, this is where you try to divide by 0. That's called a zero division. It's going to cause an error. That's called a zero division error. Then there's called an assertion error. This is where an assertion error, as we are going to see, is where you have told your program to say you should only accept positive numbers, but someone gives your program a negative number. Then that is going to cause an assertion error. Then there's an attribute error. This is where you have an object, but you're trying to access a property of this object which does not exist. So if you're trying to access a property of an object which does not exist, then it's going to cause an attribute error. This is called an end of file error. This is where I think we're looking at opening a file, right? Then Python tries to open your file and read it, but somehow it fails to reach the end of your file. So when it fails to reach the end of a file, to read your file completely up to the end, it causes an error to happen. So that error is called an end of file error. Import error. This is where the import error, you fail to import a module. Index error. This is where you give, for example, a list. A list has got items. Then you want to access the value associated with an index which does not exist. Maybe your list has got 5 items. Then you are looking for the 7th item in that list. There is nothing like that because that item doesn't exist. So that's going to cause an index error. So there are all sorts of errors. Okay, this other one here, a name error. We have seen this. This is where you're trying to print a variable which does not exist, or a variable whose value which does not have a value stored in it. So they are basically all these are all errors. Syntax error, system error, exit error, type error, value error, runtime error. All these are different types of errors. We are going to see how to work with some of them which concern us. Are we clear? So, apart from just saying an error has occurred, you can actually be more specific. If you have an idea about what kind of error is likely to occur or what kind of error has occurred. Are we clear?
Yes.
Yeah, so you can actually be more specific.
Yes.
So here, this brings us to this section which says handling non-exceptions with try except block statements. So handling non-exceptions with, so I'll say handling non-exceptions with try except block. So if you know what kind of error occurred, you can say something about that. Okay, so how does this work? So you try, again, you only put the code which is likely to cause an error in the except block, in the try block. Are we clear about this? You can't put everything. You can't put all your code in a try block. You only put that part of your code which is likely to cause an error. Is that clear?
Yes.
Yeah. So you try. So you try, then execute the code which is likely to cause a thing. Then, yeah, maybe this code actually does cause a mistake. Now, if you know the name of the mistake, we have a list of these errors here. If you know the name of the error, then you say except, then you put the name of the error. So if this is the kind of error which occurs, then you should do this. Then again, except, if this other error occurs, exception 2, the name of the exception, then you should do this. Then if this error occurs, then you should do this. Then at the end, if you run out of what you think can go wrong, then you just say except, then do this. So in this case, at the end of the except, if you don't know exactly what kind of error happened, then you can say, yeah, an error occurred. Okay. So let's see how we could better handle the situation where we're trying to print number, but number has not been given a value. And we know if we try to print a variable which does not have a value stored in it, we are going to get a name error. From up here, we know we're going to get a name error because Python helped us say the type of error which is going to occur is this one. We know we're going to get a name error. Okay? So we have an idea of what kind of error is going to cause our program to come to an end. It's called a name error. So we say try print number. So we try to print number. Then if we try to print number, then it fails. Then the first suspicion we have is that maybe the variable is not defined. So we say except name error. Then under the name error, we print an appropriate message, say variable not defined. Otherwise, if it's a different type of error, then we just say except an exception occurred. So in this case, if we try to run this, we get this. Variable is not defined. Are we clear? So for a particular error, you also print an appropriate message for that particular error to help the one who is using your computer program doesn't know that an exception has occurred. What kind of exception has occurred? So you are trying to help this person say, oh, this is a kind of error which has occurred. Is that clear?
Yes.
The other one is, where is that? Where you divide by 0. This one, 0 division error. This is another common exception, especially for us where we're going to be doing calculations. So if you divide by 0, and if you know there's a possibility that someone could want to divide by 0, then what do? So name error. And how do we know that there's a 0 division error? So you could quickly just say print 3 divided by 0 and see what happens. When you do this, when you try this, this is what you get. How do I know the name of the error? I try to commit a mistake, then it gives me this is the error you've committed. You see that how you extract information from Python? And the name of the error. So it even prints a message say division by 0. Yeah. So with this kind of error, zero division error, which is handling a 0 division error, how do you do this? When you're carrying out, you create a function, and this function has to divide 2 numbers. For example, like what you're doing here. We create a function. We're trying to tell Python we're going to create a function called divide. Then this function is going to accept 2 numbers, the first number and the second number. Then after that divide, we're going to divide the first number by the second number. Then the result. Okay? Then after that, we print out the result. When we do this, yeah, it's fine. But what we have failed to consider here is that the second number might be a 0. As we are going to see. So we do help, okay, retains the quotient of division of 2 numbers. So we say, okay, divide 20 by 10. When you divide 20 by 10, we get a 2.0. That's fine. We divide 10 by 20. That's 0.5. That's good. We divide 0 by 10. That's good. Then we decide to divide 10 divided by 0. Then we get an error. We get a 0 division error. And when you look at what has happened here, what is it that's happened? It says there's a 0 division error here. And when you look at all these, Python says, I have a problem with this statement. They divide 10 by 0. And inside this function, Python especially has a problem with this particular statement. Result first number divided by second number. So that is the statement which causes the error. It's not everything else. The other things are okay. It is that particular statement. This one I've highlighted here. That's the one which causes the error. Is that clear?
Yes.
So, now that we have identified the statement which is most likely to cause our function to fail, we are going to get this statement, then we'll put it in a try except block. Okay? And we will try to take care of whatever exceptions we think can happen. So this particular statement, result first number by second number, we are going to put it in try except block. And that's what we do here. We say try result first number divided by second number. Then after that, you try to do that. If it works, fine. If it doesn't work, then we come to the except. Our first suspicion is that there has been a 0 thing. That's our first suspicion. Our suspicion is that a division by 0 result has occurred. You only put in the try the statement you think is going to cause an error. If it works, that's fine. Then we're going to return the result. If it fails because this second number is a 0 and we say 0 division error has occurred, then we print out division by 0 like that. Are we clear?
Yes.
Okay, so we run this. Now we try 10 divided by 0. When you try 10 divided by 0, result before assignment, what has happened? Okay, maybe I should put it inside. Okay, now it clearly just tells us that division by 0. Before that, we could run one of these guys, say 10 divided by these other ones. We could say divide 10 by 20. This one runs just fine, but when it comes to this one now, why is that's still a mistake? Oh, okay, fine. So now it doesn't spit a bunch of information, just tells us that division by 0. This. So it tries to do so it tries to do this calculation. When it tries to do the calculation, then it finds that we can't do this calculation because of the 0. So that division by 0 causes an error. And now we start checking through the list of errors we know. Then we find the division by 0, then you print that message like that. Is that clear?
Yes.
There is also sometimes when you want to open a file that does not exist. You want to read a file, then this file doesn't exist. As we are going to show, there's a file which doesn't exist called white sheep. So we create name of a file white sheep, we print white sheep, then we try to open this file. We say file, that's white sheep, it's not there. Then we want to read it. When you try to do that, we get an error. The error we get is called file not found error. We're just from looking at how to open files. So we know how to open a file quite well. The only problem is we were trying to open a file for reading purposes and that file doesn't exist. Then we are given some information here. It says file not found error. No such file or directory white sheep. So what do we do? It's the problem is here. This is where the problem is. When we were trying to open the file, this bits file name white sheep print file, this doesn't have a problem. The problem is here. This is a line which causes a problem. Okay, so again we get this line, we put it in a try block, and we do things about it. Okay, so we say file object open, then the name of the file we want to open, the file, and the reason why we're trying to open the file, that. Then if it opens the file, good, we do things. We can read, write, whatever it is, that's fine. Okay, if it opens the file, if the file is opened, then we can say file object dot read. Then after that we say file object, after we read it, file object dot close. This is what we just from learning a few minutes ago. So this is what we want to do. We can do these things after we open the file, if it's there. Okay? You can open it, you can read it, if it's there. I don't know if I should put these things at the end again. I'm not sure. Because the only thing I want to put in here is what could cause the error. The other things, probably put them outside. We can put them outside, like that, or after the try. So we can say read data. Then after that we can say close file. Okay, so we only put in the try the bit which we think could cause an error. If the file causes an error, then we could print out this message. Okay, no such file. We can just say file whatever it is does not exist, or file successfully opened, like that. So now it's either we try to open, if it opens, we open the file, then we print out this message, file successfully opened. If it fails, then you're going to print out this, file does not exist. Is that clear?
Yes.
Okay, so we do that.
Yes.
So here I think these guys are supposed to come inside. Let's come inside here. Like that. So if we open the file, so here if you open, we tried that, then we try again here, inside here. There. So we just stored file white sheep does not exist. Or you could print this message. Is that clear?
Yes.
Yeah, so basically there are certain errors you know could happen and you want to take care of those, and that's how you do it. So the bits which could cause errors, you put them in this try block, then you run that bit. Then if we try the same thing with a different file, we say file name, we say black sheep, because we know black sheep exists, right? Black sheep .txt. This there's a here, I think like it's like that. We know this one exists, this black sheep .txt, right? Then we try to open it. In this case, we get a different result. We run that. Then we say it says file blacksheep.txt successfully opened. So depending on the circumstance, you want to tell this person who is, working with your thing, with your whether the file was opened successfully or not, but you don't want this kind of messaging thing here. This is very, very confusing to an ordinary user who will use your program. They will have no idea what's going on. Then at the end of the day, they might probably stop using whatever software it is or your program. Okay, and that's not what you want. What you want is when an error occurs, you want to tell them nicely, sorry, the file you have opened doesn't exist. Or if they open an existing file, you want to tell them, oh, the file has been successfully opened. Are we clear?
Very clear.
Yeah. One thing you notice here is, which is very obvious, is that we have introduced another thing, the else. When we tried to open the white shape, then it failed to open. This was run. File does not exist. When we opened the black shape, then it opened. The try thing happened, then it opened, then this was run. So when it succeeds, when you try to do something, then you succeed in trying to do something. You might try to tell the person, to inform them that, oh, this task you're trying to do has actually been successful. So you trying to tell the person this task has been successful, you can put that message after the else. Block. Are we clear?
Yes.
Yeah. So there are two things here. Either the file opens or the file doesn't open. So if the file doesn't open because of an error, this file not found error, then you want to print out this message. If the file opens because it has been found, then you want to print out this message. File has been successfully opened. Sometimes you also want to handle an error which you do not know. There's these errors which we know, but sometimes you don't know the error, what it's called, but you just know that an error has occurred. In that case, if you want to, you want to also cover your all the sides, and also cover for the case when an error occurs. For example, instead of dividing by a number, someone decides to enter a letter. So you're dividing 5 by 2. What is supposed to happen? Is that clear? There are all sorts of ways an error can happen. In such a case, where you are sure it's not a division by 0, because here, as you can see, we say divide first number, second number. We try to do something, then the result, we return the result. Then if there's an error, we check for a division by 0 error, then we print division by 0. If there is another result, there's another error which has occurred, but we do not know about it. Maybe because someone wanted to divide a number by a letter, or a letter by a number. Okay? Maybe they were thinking this number or this variable or this name has got a value, but it turns out it doesn't have any value in it. But so this is something you can, maybe you can foresee it, but maybe you can't. So you just want to say there's been an error which has occurred. So in that case, you can just say, after you have listed all the errors you think can happen, which you know by name, okay, after that you can just say, except this kind of error has occurred. Oh, Brian was trying to get back in.
Think so.
Yeah, sorry. Can you try? Can you? He needs to try again. Okay, so you put an except there. This is just for covering any type of error. You don't even know exactly what kind of error it is. Like that. Okay, so here, for example, we divide 10 by 2. That's fine. Then here we divide 5 by 0. That's okay. We have covered this. This is division by 0, right? Then here you have a person trying to divide a letter A by 3. We have not covered this kind of error. We know it's going to cause an error, but we haven't covered it. So the only thing we're trying to do is we're going to say, oh, an error has occurred because of this. So we say an exception has occurred. This is when you're trying to cover for an error which you do not know. Are we clear?
Yes.
Yeah, when you're trying to cover for an error which you do not know, just say an exception has occurred. So the way we handle errors is, you first of all, you look at that bit of code, like in this case, which is likely to cause an error. You put it under a try block. Then after you put the code under the try block, you think about what kind of errors, what kind of situations could cause an error. Then you list them. For example, 0 division error, you list them with appropriate messages for the users. Then once you have run out of things to list, you can just say except an error has occurred. An exception has occurred. Is that clear?
Yes.
You can go further than that. You might try to seek information about what kind of error has occurred even if you do not know it. Okay? You might try to get a bit of more information about the error which has happened even if you do not know it. And that's where we're saying here, getting additional information on unknown exceptions. Getting additional information so you can actually try to get more information on this exception which you do not know about, so that you have an idea of what is going on. So we're going to go back to this same example. We're going to add something here. Instead of just saying an error has occurred, we're going to add something. So we say try that, return result here. We add something, say return result, then accept that. So this one we know, but when it comes to this other one where we do not know what kind of error, we are going to we're going to import a module called sys. This module called sys. Then this module called sys, when an exception occurs, this module has a function which can get you information about that module, about the error which has occurred. And how do we get the information? It's this. We say sys dot x. This is exception information. So this, when an error occurs, this is going to access information about an error which has occurred. Are we clear?
Yes.
I don't know if I can try to do a quick one here. Let me say import sys. Then after import sys, I want to say, let's say print this. We know that's going to cause an error. Then I want to say error. Sys dot accept info. Then I don't know if it's going to work. I don't know if it's going to work. Let's see. No, it doesn't work this one. So it cut here. But anyway, I think with the other thing we're trying to do, it actually works. So inside the except here, because this except has to run inside the except, because an exception has been created inside the except, you import this, then you get the type of error. Then after you get the type of error, you say print an exception has occurred, then you print the error, then you can actually figure out what type of error has occurred, like that. So we run that. Now we run this one, the a divided by 3. We run the a divided by 3, then this is what we get. This is what we get. We get a bunch of information, but we get something. So there's this one, this we already know, that's what we said. We just say an exception has occurred, but we managed to extract information about the error using this sys exception info. And what did we get? We got this. You know, this is a parenthesis. That is another parenthesis. And what you see is a tuple. So this is actually a tuple with information. There is this information, then there is this information, all the way up to here, then there is that information. So you've got a tuple of information like that. The information we are actually interested in is probably this one, a type error, and also this one, unsupported operand types for division. So we have string, and the most important information I think is this one, the second one, the type error. So instead of just printing error, we could also actually do the following. You can say print error. Then after that, since it's a tuple, we look at this one. This is a first index, 0, then 1. That error, we could print more specific error information. Then we run that. This is what we get. Like that. We could even combine this, a bit of this, and that. The two. We could say print error first, the first error, 0, then next we put this, then next we put error, so that we can draw something more specific. We can print out a more specific piece of information. We run that. So this is what we get. Class, type error, unsupported operands, that. So that is basically more useful. So we can actually now, after this, we can comment out this bit. We can also comment out this bit. We can also comment out this bit. Comment out those bits, we run that. Now we have got something more specific. So now we have got information about this. We have information, we know that an exception occurred, okay? And we also know the type of exception which occurred and the description. In this case, we tried to divide a string and an integer. So this is us using another module trying to get information about what kind of error has occurred. Is that clear?
Yes.
Yeah, so that's how you do it. Because like this, you're trying to be more useful to the person and say, it looks like when you carry out this kind of division, it causes an error. So that's how you would get more information about an error which you do not know anything about. So you run that there. So this one, I think let's leave these the way they are, since we have modified the function down there for learning purposes. The error print not type, or let's say print 0. I'll do this print 0. That, yeah, I'll do that. Okay, then you combine them. Okay, here, yeah, then you get that. Same applies here. When you do that, when you run it, you get something similar again. So the previous one, which was a divided by 3, you get string int. This other one, it was 10 divided by a, you get int and string. So things are changing, but the kind of error is the same. You're still able to get information about this type of error. Are we clear?
It is clear.
Here. Okay. I want to get this last bit. I want to put it here. Yeah, I want to place that statement there. Of course, there are other things which are not very, they are there, but exactly what they do, I still also don't get it very much. Like finally, and yeah, the else thing, we have seen that when we are whatever it is you're trying to do under your try block, when it succeeds, then also whatever is under the else is also going to be run. So you've seen that. But there's also the finally one, which for me kind of like, I don't really see exactly where it falls. So for example here, you have a try, then you try to carry out something which could cause an error, then you check for the exception, maybe it's a name error, you execute this code, there's another exception, then when you run out of whatever ideas, you extract your information, then you can also do a finally here, which I really don't know exactly, I'm not sure exactly what it does. So like in this case, where you divide, we try to do that, the try thing. So we say return result here, return result, then your division by 0, then here we try to get information about the error, we print that out, then if this one, the else, so this is going to be printed out, this piece is going to be printed out if some other kind of unknown error occurs. This one here is going to be printed out if a division by 0 occurs. Okay, so we try to do this. This is going to be printed out if division by 0 occurs. This piece of code is going to be printed out if an error we do not know about occurs. Then if we are successful, we divide things we are successful. If we are successful, then you say print division not successfully done. I think that's not correct, because I think it's going to run. I think it's a division successfully run. Then this other one, so I think the else runs when this is successful. What you're trying to do here, when it's successful, then the else is going to run. Then there is a finally. The finally thing, whether something is successful or not successful, it always runs anyway. So what you put after finally, whether your division has been successful or your division has not been successful, it is still going to run. Does that make sense to you?
Yes,
Yeah.
it does.
So what you put here, if the division is successful, what it comes under the else is going to run. If your division, after that, what comes under finally is also going to run. if your division is not successful because maybe you divided by 0, then this is going to run, and what comes under final is going to run. If your division is not successful because of some other reason, error you don't know, you want to, then this is going to run, and the final is going to run. So let's see. So we divide by 10, 10 divided by 20. With 10 divided by 20, this is what you see. I will always run. So this one was not, so the else was not run. So division, so that's division not successful. So the else was not run. So basically our division went through with the result. We got the result 20, and this one was printed out. I will always run. There, we with 0.5. Then when you divide by 10 divide by 0, so this is going to cause an error. We know that because this is going to be a 0 division, right? We're dividing by 0 here, so that's going to cause an error. So we expect to print this, that. So when you run this here, division by 0. Okay, then again, this bit, whether there's an error, as you can see, whether there's an error or no error, it still runs. Here the division was successful, it says I always run. Then here, division by 0, I always run. Then we try to divide by a, again we see that, oh, there's an error, an exception has occurred, which is this bit. An exception has occurred, which is this bit. This one here, an exception has occurred, and we get some information about what kind of error has occurred. Then it says I'll always run. So I'm not very sure about where the else is. About else, this bit, you have to forgive me, I'm not very certain. I might mislead you on this one, where exactly it works. But that's, anyway, I have to read more a bit so that we can figure out where that is. So that is about the errors. The last bit we have to talk about is something called asserting. My internet connection.